Hello everyone. In this section, we will discuss about hyperparameter tuning with the HParams dashboard. So these are the topics we are going to cover. First, we will discuss what is a hyperparameter. Then we will discuss the implementation of HParams by using TensorBoard dashboard. First, we will discuss what is a hyperparameter. So basically, as you remember, how you used to tune the radio to improve the channel bandwidth for better sound quality and less background noise. So for this you have to set the frequency in a radio. Similarly, in machine learning, you can improve the accuracy of a model by tuning hyperparameters such as a learning rate. So in neural network design, hyperparameter values help the model to find the weights of a node to learn the pattern of an image or text. Basically, hyperparameters are the parameters whose values are tuned to obtain optimal performance for a model. Hyperparameter tuning is also known as hyperparameter optimizations. So, model optimization is a continuous process as shown in the image. So, first we will build a model. After that, we will train the model and then we will evaluate and then identify the model by using model.fits and improve the accuracy, and then we will select the h-param values. So you can tune values for the following parameters: number of units and nodes in the dense layer. The second one is learning rate. The learning rate is a very important parameter of the algorithm. Different learning rate values can significantly affect the behavior of gradient descent, and the range value is between 0.0 and 1.0. The next one is dropout layer. It has many arguments from machine learning systems. However, overfitting is a serious problem in such networks. And most of the time, by default, the dropout layer we are going to use is 0.2. Next is optimizer. Optimizer is basically a technique that is used to decrease loss by modulating different parameters and weights. Hence, it will minimizing the loss function for better accuracy of the model. Next is regularization. So basically, it is the sum of the square of all the feature weights, and lambda is the hyperparameter tuned to strike the balance between simplicity and training data fit. The second last one is epoch. This parameter indicates the amount of time that the learning algorithm will take to execute through the complete training set. For example, a Eminist has 60,000 images, so one epoch means going through all 60,000 images at once. The last one is activation function. Activation function has the responsibility of which node to fire the for feature extraction and finally output. Now we will discuss the TensorBoard HParameters dashboard. So basically this is used to optimize and debug TF programs, and for this reason TensorFlow has introduced a TensorBoard, and TensorBoard basically helps the user to visualize the TensorFlow graphs, and it will focus on hyperparameter values which we are going to use in HParams dashboard. So now we will see an implementation of HParams by using TensorBoard. In this example, first you have to install the latest version of TensorFlow. Now, to able to use the TensorBoard, we must load the first TensorBoard extension by using this command. After that, I created a log folder variable and assigned the directory in it. And for reload the extension, we use this command, that is --reload extension TensorBoard. After that, I will import the required libraries like TensorFlow and datetime. Now I will load the dataset, and for this I am going to use the Eminist load dataset by using the command tf.keras.dataset.eminist. After that, I load the train and test data as xtrain, ytrain and xtest, ytest. Since the input features are between 0 to 255, I will just normalize it by dividing 255. After that, we have experiment with 4 hyperparameters in the model. The first one is number of unit in the first dense layer by using hp.h parameters. After that, dropout layer, and the range values start from 0.1 to 0.2. In the next, we have assigned the optimizer, that is Adam and SGT, and given the path of the directory. After that, I have assigned a variables, that is hparams and matrices, and use the variables in it. Next, the model contains 2 dense layers with a dropout layer between them. The hyperparameters are not hard coded, although the training code will be similar. So all the parameters are provided in HParams directory. So after that I created a new sequential model with a single dropout layer as model tf.keras.sequential. So in the first layer I have created a flatten layer. In the second layer I have created a dense layer with mention the HParams with the kernel regularizer and the activation function that is real. Next we use the dropout layer, and in the end we have used the dense output layer and with the softmax activation function. Next I have used the model.compile and assigned the optimizer, loss and the matrices in it. For fitting the model, I have assigned the X-train and Y-train and set the approach value, that is 2. So in the end, we have created the session num for running the session and given the path of the directory in it. So as you can see that epoch value has been generated and loss value is 0, and it will mention the loss and the accuracy values. So this is the TensorBoard HParams dashboard. This is the num units, dropout, optimizer and the accuracy value that we have mentioned in the approach value. So with this we have completed the hyperparameter tuning with the HParams dashboard.